Yes, class. Am I audible?
Yes, ma'am.
All right. So see, in the last class, we had completed the pulley related problems. Now in today's class, we have to start with this topic, friction. So friction is a very important topic for all of you because this is the force from which, from this lesson, this force will start friction and it will continue throughout. So you have to identify in which cases will friction be existing by itself. All right, now the few concepts which we have already studied in the previous lessons, like frame of reference. When we had started with motion in a straight line, that time also we had discussed basic terms like frame of reference. So frame of reference means what? Frame of reference basically means the place of observation, the place from which you are giving your observation. Like if you are sitting in a car and observing the movement, or you are also moving within the car and observing the movement, or you are at rest sitting in the, standing on the ground and observing the car moving. So all these different places, these are known as frames of reference. Fine. So inertial frame and non-inertial frames, we have two types of frames. So for non-inertial frames, you have a different separate force which we call as the pseudo force. That we'll talk about it differently. But inertial frame and non-inertial frame, basic differences between the two you should know. Now inertial frame is what? Inertial frame is the frame which is at rest, or it is in uniform motion with the earth. Inertial frame basically means your system is at rest. When I say no, the frame is at rest, this means your system is at rest. If the system is at rest, or it is in uniform motion with earth. Uniform motion with earth means earth is moving. So one quantity is constantly moving with this. This is what is known as inertial frame. So you can apply all the three Newton's laws which we have studied. All of them are valid. Now, next you have is the non-inertial frame. So what is meant by non-inertial frame? Non-inertial frame basically means when your motion is non-uniform or your entire frame is not at rest, it's either accelerating or it is in non-uniform motion with earth. For example, something is moving around the earth, but it is at non-uniform speed. It means the earth is either the earth is moving fast or the object is moving very fast, or you can even say the object is changing the direction, whereas the earth's direction is different, or the entire frame which we are talking about. For example, if I give you a hint, if I give you an example, if a truck is there and I have hung the pendulum from the ceiling of the trunk. Now, when that truck is moving, so the pendulum is resided within the trunk of the truck. So truck is moving. Now, pendulum, what will happen to the pendulum? If it was like this initially, now as soon as the truck has started its motion, pendulum will move. Now all the movements, all the forces which are recorded in there, what will happen? Those will be considered under non-inertial frame. So some other forces will also act. Newton's laws will not be valid over there. They can be valid, but they are not always valid. So what will happen? Because your entire system, that was your truck has also started moving. Means frame of observation, frame of reference, your frame has started moving. This is what is meant by non-inertial frame. So you have inertial frame and non-inertial frame where Newton's laws are invalid, and you have a concept of pseudo force. All these you can write down later. Or do one thing, write down these 2 points, then we'll start properly from friction. Note it down. Done, class? By now you must have completed it.
Yes, ma'am.
See, let me start with friction then. Frictional force, all of you have already heard of, right? Frictional force, this is not a new force for any one of you, but frictional force, some things will be new for you in class 11, some things you have already studied in your lower classes. And I think 9th standard last you must have studied regarding friction. So what exactly is friction? See, when two irregularities, suppose this is a surface, when you zoom it up, you see the irregularities of the surface. Usually we are not able to see the irregularities from our eyes, that is a different thing. But if you go into the intermolecular structure, you notice that there are irregularities present. Likewise, there are irregularities present on the other surface also. Whenever there is no motion, what happens? These get interlocked, right? They get interlocked on each other. Nothing is generated, no force is produced, rest of the forces are acting, no topic of friction comes into action over here. Now see, as soon as we talk about, now these irregularities are already present, now what will they do? Once the motion has started, let's say both the bodies, these are moving, they have started their motion. They were at rest like this, now they have started their motion. So what is actually happening? The irregularities which are present, they are now getting past each other. So they are actually rubbing each other. So that rubbing generates heat, which in turn generates a dissipative force in your system. So that dissipative force in your system, this is known as your frictional force. This happens only when the irregularities rub against each other, because the corners of all the irregular surfaces, more your irregularity is present on your surface, more is the heat produced. So all of the work done is there, whatever work done is there, that actually helps in transferring electrons, that transfers the electrons. And there are a lot of molecular mechanisms if you go into the details and if you keep on exploring it. But what you have to remember is that now, if irregularities are present, if something is smooth, suppose this is a smooth surface, now this is past sliding it, see how smoothly is it passed. But because of presence of irregularities, which had to be very smooth, now these are getting stuck. This is becoming congruent now, this is getting stuck. So this is actually providing a little resistance to your motion. The motion which could have been smooth like this. See, if these are the plane surfaces like this, and if you slide them, you can notice they are smoothly getting slided away. But as soon as the surface becomes irregular, there is a viscosity experience, or the density is high, where you feel a portion of resistance, right? So that force we call as the friction force, and this is the reason why it opposes the motion. Whichever direction is there, friction will act opposite. Why? Because friction's work is to oppose the motion. If the body is moving towards the right, friction will act towards the left. If body is moving upwards, friction will act downwards. Any direction, it can be any direction, but it has to be opposite to the direction of motion. It's a dissipative force, means it's a wasteful force. We often call friction as a necessary evil, because we know sometimes we require friction. Without friction, so many things will not be impossible. But since it opposes the motion, that's why we call it as a necessary evil. Both the things, pros and cons. And this is not of a single type. Let us discuss all the three types of frictional forces which are available. First is the static force. You must have heard of all these. Limiting, and last is kinetic. Now we'll discuss all of these three together, because this is talking about a single frictional force only. No, suppose, let's say I have this block. For example, I have a block. Let's say I have a block. Fine, this is a block. Now I have applied a force of 1 Newton. Fine, let's say I have applied a force of 1 Newton. This is the force I'm applying, 1 Newton's force. There is the same thing happening. Let's say F is equal to 1 Newton. This is my applied force. body is not moving. Though I have applied 1 Newton of force, but I'm seeing the body is not moving. What is happening to the frictional force now? Force is being applied, body is not moving, but force is being applied. There will be a frictional force which will be in opposite direction of the magnitude 1 Newton only. This is the frictional force opposite to the applied force. This is the frictional force. Now I have increased the force. I was applying 1 Newton of force. Now I'm applying 2 Newton of force. Now what is happening? I have increased the force to 2 Newton. All right. This is now what I'm seeing. This friction force is also 2 Newton. The body is not moving. Both are exactly the same. Now what will I do? 1 Newton, then 2 Newton. Then as soon as I apply 3 Newton, I see motion has begun. Just there is a beginning in the motion. See, when there was, the force was 1 Newton, nothing was there. 2 Newton, nothing was there. As soon as the force is 3 Newton, you notice there is a slight motion in there. This is 3 Newton. Reason is that frictional force is still 2 Newton. Beyond 2 Newton, there isn't any possible value of frictional force which is existing, right? I have applied force, let's say 10 Newton. I have applied the maximum force, which say, let's say this is 10 Newton, right? What is happening to the frictional force? This is still 2 Newton only. That's why the objects are able to move. Otherwise, if there wouldn't have been any limiting or kinetic friction, the bodies could never move, because whatever force you apply, same force the nature will apply. Whatever force you apply, this will keep on going on until and unless the body moves. But here what happens? We notice that the objects move. If I push it, this is able to glide itself. Why is it able to glide itself? Why my phone was able to glide? Because the frictional force was less as compared to the applied force. So what exactly are we studying? All of these forces. So what is exactly your static friction? What exactly is your static friction? So this is the friction which is acting when the body was at rest. In the example, you will only tell me what was static friction and other friction. It is the friction which occurs when the body was at rest. Motion has not started yet. And this is self-adjusting. See, when in this example, look here. In this example, when I applied 1 Newton of force, frictional force was 1 Newton. So this is the static friction. This is the static friction. The body isn't moving. When I applied 2 Newton force, notice static friction is self-adjusting. It became 2 Newton itself. So it adjusted by itself, right? It adjusted by itself. So when I applied 2 Newton, when I increased my force, it also increased its force. So this is what is meant by static friction. So it is the friction that acts on the body at rest. Actual motion has not started yet, and it is self-adjusting in nature. This is the first type of friction force. Second type is, see, what exactly is this 2 Newton I'm talking about? After this 2 Newton, is there any value of frictional force that is possible? Is there any? Let's make it as 3. Let's say till 3 Newton also this was constant. After 3 Newton, this began its motion. Let's make this example a little more lengthy. So this is 3 Newton, 3 Newton. You can see this is the maximum value before the motion could occur. Right. So there are certain values of static friction. Initially, the force is very less. The applied force is less, so frictional force is less. Then it increases. And a point comes when the body begins its motion. So this maximum value of static friction, beyond which the body begins its motion, this frictional force is known as the limiting friction. Abdullah, you are asking something? No? Okay. So yes, so limiting friction it is the maximum value of static friction. So you can say actually the frictional forces are of two types only, the static and the kinetic, means one when the body is at rest, one when the body is moving. But to make it more easier and enhance the classification, we have three types, because static is not a single constant value. No, in static is self-adjusting. Static is constantly changing its value. Yeah, right, it is continuously changing its value, 1 Newton, 2 Newton, 3 Newton, depending upon the applied force. So last value static friction, no, that is what we call as the limiting friction. Now when the body has begun its motion like this, now the type of friction which will keep on acting is your kinetic friction. That won't stop the motion now, because its value will always be lesser than the limiting friction. So it acts when the body is actually moving over another body, and it is always less than limiting. Why less than limiting? Because if it is more than limiting, means it is static, and static won't allow the body to move. So always the body's value will decrease. Here in the example I haven't mentioned, actually it decreases. So let's revise it graphically. Let's just revise quickly it graphically. Frictional force you have on the y-axis, and on the x-axis you have the applied force. Now when you are increasing the value of applied force, value of frictional force is also increasing. Then you are again increasing the applied force. Then again the value of frictional force is increasing. Again you have increased. So there is a value you can notice that constantly your graph was increasing. Applied force is increasing, frictional force is increasing. So this particular force we get, that is known as the static friction. This is the static friction. Now a maximum value has been obtained, after which, beyond which it cannot increase further. So this is known as limiting friction. And beyond this, now the value decreases a little and it remains constant throughout. Because once the body has attained its motion, it will keep on moving. Now here you get the kinetic friction. And regarding the causes of friction which are mentioned, we have already discussed the cause. See, if one surface, no, it is actually like this, the edge of one surface, and edge of another surface is like this. So when the bodies are rubbed against each other, they collide. These irregularities actually collide among themselves when the applied force is there. So that's why the frictional force comes into its opposite direction when the two irregularities come. There is actual reason, no, for generation of frictional force is that this you will study in electrostatics in class 12. You have this concept of charging by friction and all, that time you will study. Basically the charges which are present, they are producing electrons over here. I think mentioned also before. So which is actually in turn the heat, producing heat, which is leading to production of frictional force. So no need to go into the details. This is enough for you. And all of you already know that intermolecular force between two surface cause friction. Even if you rub your hands, after a certain time, you will feel the hands are warm because of heat due to the frictional force, right? Laws of limiting friction. No? Okay, note down it till here. Then we'll study the laws of limiting friction, because from laws of limiting friction, your numericals will start. Though frictional's direct formulas, no, is very easy. One formula you have that you have to remember. Note it down, we'll discuss.
Now can you scroll up to kinetic friction?
Are you asking something? I just wanted to scroll
No,
it.
no, I just scroll
Okay,
kinetic friction.
okay, okay. See, class, now after the causes of friction, the laws of friction. So there are two laws of friction which you have to remember. First is that friction depends upon the normal reaction. Now let us talk about the normal reaction. Normal reaction is any force which acts perpendicular to the surface when two surfaces comes in contact. Two surfaces come in contact. Like this is one surface, this is another surface. They are in contact. So perpendicular to the surface of contact, a force always exists. This is known as normal reaction. For example, there is a wall. This is the wall. And on this wall, I have kept this device. All right, I have kept it. This is just in contact. So how the normal reaction will now act? The normal reaction will now act like this, perpendicular to the plane. This is the wall, this is the surface. So now this acts perpendicular to the plane. So whenever you have two surfaces, they are in contact, a normal reaction comes perpendicular to the surface. This is not necessary that the surface has to be horizontal or vertical, any condition. No. The surface can be in any manner, it can be inclined. You have questions, you have so many questions on inclined plane also. There you will see that a normal reaction can occur anywhere. So for example, this is a surface that I have, mass of block is m. So this is mg is the gravitational force that is acting downwards. So normal reaction will always act perpendicular to it. This is a rough surface. For example, if this is a wall, this is the surface. Why am I saying? Because when these types of question come, no, then students forget how to write normal reaction. They still draw it like this. No, you have to draw it perpendicular to the surface. Perpendicular to your surface would be this, though your gravitational force act will be acting downwards, right? So this is how you have to write it. So your frictional force depends upon your normal reaction. This is the first law of friction. And secondly, it is independent of the area of contact. What yes, third law is also there, that it increases with roughness. This is not actually a proper law, but when laws of friction come, you can state that law. What are you asking, Abdullah? Law, you are asking about the law. Law is this: force, frictional force is directly proportional to normal reaction. Yes, Abdullah, what are you asking? Okay, okay. Law, no, you're asking. Yes, yes. The law is this only. See, suppose let's talk about limiting friction. All right. Now here you will see frictional force is directly proportional to the normal reaction. So if something is proportional to something, you always put an equal to sign with a constant, right? So here the constant that comes is not a k that we write is the letter mu. This is a Greek letter mu. It is written like u with a little more length in comparison to uv, right? So F is equal to mu n. For limiting friction, we just put the symbol L so that we are able to differentiate all the frictions. So what is FL? This is your limiting friction. What is mu L? This is coefficient of limiting friction. And what is N? N is the normal reaction. So actually your law of friction is this one. Fine, this is how you write. And whatever now your normal reactions value would be, suppose here in this question, mass acceleration due to gravity and your mass that makes your gravitational force is acting downwards, mg. Here your normal reaction is equal to mg. So your frictional force will become mu mg. Whatever values of normal reaction you are getting, that will become. All right. And one more thing, always remember mu L and mu S are same. Now, what is mu S from here? Mu S is same thing. This is coefficient of static friction. So static friction is also directly proportional to normal reaction. So static friction is equal to mu S N. So actual values of mu S and mu L both are same. All right, this is your limiting friction. Let's just see one question so that this is an easy question. For the example purpose, we can take it. See, this is a question, just this part is given to you from the question. This is a question where you have to find out the frictional force. So since this is a surface in contact, it would be perpendicular, a normal reaction would come. And because it has a mass, so gravitational weight will come. We call this as weight. More details of mg and variations of mg, you have a separate lesson, gravitation, that time we'll discuss. Now, what is the value of frictional force? F is equal to mu n. Here your normal reaction is equal to mg. So your frictional force is equal to mu mg. Mu is 0.3, mass is 10, acceleration due to gravity is 10. So that becomes 330 Newton. This is the answer. Friction is 30 Newton. Like this. Note down it till here. Some more questions we will practice from this. From here. Laws of limiting friction.
The third one, friction increases with what is written there? Like the third one point, like what is written there?
Yes, third point you're asking, Martin.
I'm asking what's written, like friction increases with what's written?
Here, second,
No.
in which
Third
point?
one, third one.
Third one. This says that friction increases with roughness.
Okay.
How are we multiplying 10 into 10?
Ma'am,
See,
the value
mass
of
is given as 10 kg and acceleration due to gravity, mg, that I have taken it as 10. You can take it as 9.8 also. Your answer would be exact 28 point something. All right, Harsha.
ma'am, so the normal force would be equal to both mass and gravitational force.
The normal reaction is equal to mg. Mg is your gravitational force. What is the formula of force we have? F is equal to ma. So if your gravity is acting, so acceleration would become acceleration due to gravity. So which we also call as the weight of the body. So weight of the body or the gravitational force which is acting downward is mg. So that becomes 10 into 10, which is approximately 100. I am taking it as 10. You can take it as 9.8 also in your answer, because we should take 10 only when it is given in the question, right? And now F is equal to mu n, but your normal reaction is equal to mg, that is 100 Newton. So multiply 0.3 with 100. So that would become 30 Newton. Fine, Harsha?
Yes, ma'am. Okay.
All right. Now one more question before we discuss limiting friction. A body of 20 gram is placed on a rough surface having coefficient of static friction as 0.3. You have to calculate the maximum static friction that can be exerted. So suppose this is a body, this is 20 grams of force can be present. Yes, let's start with you, Yasir. What are all the forces that are acting over here? This is the rough surface, they are in contact over here. Just tell me the forces which are acting. What do you think? If we draw the FBD, free body diagram, what are all the forces that are acting on this particular body, 20 gram, which is placed on this rough surface? Yasir. Martin.
Yeah, ma'am.
The forces that are acting?
US equal to 0.3.
Just tell me the name of the force, the name of the force.
Or the normal force.
One force that acts perpendicular is perpendicular to the surface, Martin.
Static.
Normal reaction.
Yeah, normal. Yeah.
Normal reaction. All right, this force that acts perpendicular to the surface is the normal reaction which is acting. Apart from this, yes, Harsha, any other force you think that is acting here?
Gravitational force.
Gravitational force, perfect. Gravitational force will act downward. So these are the forces that are acting. This is also a very easy question. mg, that is the gravitational force, which is the weight of the object. This will act. Now, normal reaction is equal to mg. Mass is 20 grams. We cannot use grams, so we have to put in 10 to the power minus 3. This is now into kg and 10. This is the normal reaction. Frictional force is mu n. Since your n is equal to mg, we write it as mu mg. So frictional force will become 0.2, I think it is. 0.3. This is 0.3. 0.3 into 20 into 10 to the power minus 3 into 10 would be 0.06 Newton, like this. Now see, this is not just a formula for your static or limiting friction. If you have kinetic friction also. So in kinetic friction also, your kinetic friction is now proportional. This is also proportional to the normal reaction only. And when you remove the proportionality sign, you get a constant. This constant is coefficient of kinetic friction. This is just the difference. See, this becomes your kinetic friction. This becomes coefficient of kinetic friction. And again, this is your normal reaction. So if questions are based upon this also, like a car is moving with this velocity, you have to find out the coefficient of friction. Is this value v is equal to 20 meter per second necessary for us? No. See, if we write frictional forces mu k n, what will be the normal reaction? If a car is moving, normal reaction will be equal to mg only. So kinetic frictional force will equal to mu k mg again. So that makes it 0.4 into 5 into 10, right? So this becomes 4 into 5. This is 20 Newton, like this. This concept should be clear to you, that if a body is there, when you draw its FBD in the last class, I have told you free body diagram, when you isolate the body and write all the forces which are acting on it. So normal reaction and here mg, they are balancing each other. In this case, if any other force is acting like buoyant force and all, there are lots of forces which you will study slowly. So if all those forces are also acting and they are equal to normal reaction, you will mention it. You have to mention it properly. Since in these questions, all these are equal to normal reaction, that's why we are using this. And this is the very basic type of question. All of you should be able to solve at least this much part by now. F is equal to mu mg, F is equal to mu n. These types of questions. Some more questions let us see, but before that, note down all these.
I'm going to go back up.
Yes, tell me the answer for this question. Coefficient of static friction is 0.2. 20 Newton of force is acting here. 20 Newton of force is acting perpendicularly here. 30 kg is the mass. What should be the frictional force? All of you should try. Send your answers to me. I'll discuss them. Yes, so only Harsha has answered and she has answered correctly. See the forces that are acting. Perpendicular to the surface, here you will have normal reaction. Downwards, you will have mg. Now, frictional force is equal to mu n. What is your normal reaction balancing? Is it still balancing your weight? No. This normal reaction, you can notice here, this is balancing this force, this applied force. So your normal reaction is equal to 20 Newton. So what is your frictional force? 0.2 into 20. So frictional force is 4 Newton. Note it down. Not 60. See, you must have taken this 30 into 10, right? See, that's what I was telling you. Normal, your frictional force is not directly proportional to mg. It is directly proportional to n normal reaction. You have to check where the normal reaction is equal to. Is it equal to mg? Is it sometimes it is equal to mg cos theta, mg sin theta, some component of mg. Sometimes it is equal to some different force. So that you have to check. Is it clear?
Yeah, ma'am.
All right. Note it down and just text me when you all have completed. I'll stop here because rest of the questions are lengthy. So that we'll complete in the next class. Done, everyone?
Yeah.
All right. So you people can leave for today's class. This is done. Please revise friction and come on Thursday. Firstly, I'll ask you the formulas and everything, basic theory part. Then we'll proceed to the rest of the numericals. 1 or 2 topics are left from this, angle of repose and angle of friction and all. Then this lesson will be over.